Okay, and hello and welcome back to the Programming Bootcamp. Hi, Nora.
Hi.
In this episode, we are going to talk about regular expressions or regexes. So let me share the screen. Which screen? Sorry. Yes. Okay, so this is the screen. And so my name is Gabor Sabo as always, and here we are. Let me drag this thing here. Okay. And here we are, and we are talking about regular expressions or regexes or regex. It has various names for it. Now, if any of you have learned regular expressions in mathematics in school, it has nothing to do with this at the end. Okay, so originally maybe it came out from sort of the same idea, but what we have in programming, they're not regular in the mathematical sense anymore. So what is this regular expressions or regexes? It's basically a tool. It's basically a separate language, okay, that we can use inside Python and inside a lot of other places, specifically for matching textual data. So it's an idea. Think about it as an idea. Think about it as a separate language. It's a very small language. It has only about, these are the special characters of it, or the signs in it. It's a very dense language. So you will see that in 10, 15 characters of a regular expression, you can express things that otherwise you would need tens or hundreds of lines of programming. And therefore, it's also rather difficult to read, of course, because all this information is in there. But once you learn how to read it, and once you learn these few letters or signs, then suddenly you will see that it has you can have superpowers with this. Okay, so it's also not a single thing. So what we're going to learn is primarily what's in Python, but when you can also use regular expression in all kind of other places, and I would say that they are dialects of regular expression. So the idea is the same. In many cases, the characters, the signs are the same, but sometimes one of them has some extra features in one place, other extra features in other place. Some features don't exist here, exist there, and sometimes the meaning of the special signs are sort of reversed. The whole idea is that once you learn the general concept, then you can get away. You can use it in all kind of places. Actually, I think I even showed you in Notepad++ a little bit of it.
Yeah, just a small example.
Right. I won't be able to show it right now because right now I'm using Linux, and I can't run Notepad++ here. But anyway, we are talking about the one in Python anyway. So let's talk about a little bit more in details. So what are what are regular expressions good for? For example, you have a large string coming from a text file basically, and you are trying to find if some smaller string is part of it. Now you could, we already had the index method, but that's when you know exactly what you are looking for. But what if you were saying, okay, I'm looking for something that has 3 digits in it, and you don't know what digits, okay? Or these kind of letters, but I don't know what exactly, okay? Then you can't use the find function of the regular Python, but regular expressions can be done. So it's something when you you're looking for something that you have a very good definition for it, but it's not an exact match. It needs to be flexible. You get some input, for example. That's another case. You get some input from me. Well, let me enlarge this. Okay, you get some input from the user, and you want to make sure that it's in the right format. Let's say it's a decimal number. It looks like a decimal number, or it looks like a hexadecimal number, or some format that you expect there. I don't know if you've encountered this. I've just had to get some refund for an airplane ticket, and it's very common these days. Okay, in the email that they sent me originally, I had the ticket number, which has 3 digits, a dash, and then I don't know 7 digits. When I had to, and then I pasted this into the web form of the requirement, and they said it's not correct format. I had to remove the dash in the beginning, and then that was the correct format. So it was just a stupid decision on their side. But for is the correct use of regular expression, I could have actually expected either one. So I could say, okay, I need to have 10 digits. Somewhere there might be dashes or spaces. I don't care. Okay. And that could be much more flexible in these forms. And I'm sure that you encountered many of these forms that they are really too strict, and you have to type in a phone number, and then they exactly need how it needs to look like. And usually, and it's also not the way they are displaying in some other place. So that's okay. You might want to find a repetition somewhere. Okay, same string twice, but you don't know what string. You just say that, okay, something twice. The DNA, think about in a DNA. You're looking for some repetition, and you don't know what. Okay, you want to fetch out to grab some part of a string. You would like to cut a string up to parts. Okay, we know split, but you would like to make it a little bit more flexible. Okay, cut it everywhere where it's either this character or that character. Suddenly split doesn't work. I think we even had something that we encountered. Do you recall what? I don't remember.
I don't remember exactly what it was.
Okay.
But yeah, I remember we had this problem before.
Yeah, okay. And finally, we can also have, you can use the same idea of regular expression to changing parts of a string. Okay, just as when you are looking at the text editor, you have the search functionality, and then you also have the search and replace functionality. The search functionality can still work as a regular expression, and then you have something to replace it with. Okay, so that's just a couple of things. Now, just to show you a couple of more of these examples. So which one is a number from here? Okay. It all depends how do you define number. I mean, you can say that this is a hexadecimal number, right? Usually people won't say that this is a number, but there can be some place where you would like to expect it. Again, the word that repeats 3 times, or some text repeats 3 times. Replace all the occurrences of Python or Python by the word Java. But make sure that if there is Monty Python, you don't replace it. Okay, because you just want to replace the word Python, the programming language. The phone number thing. So you have some text that looks like this, and fetch all the phone numbers and make it flexible enough to be able to accept all of these formats. Okay, you have some text, and you'd like to look for credit card numbers. It can be very useful to find credit card numbers somewhere, okay? And credit card numbers have some certain formats, the number of digits, and sometimes people write with spaces, sometimes without spaces, so you need to be flexible. Again, another thing, you might want to look for the word password in a text to see if someone by mistake, for example, prints out the word password and probably followed by a password. Okay, then you might have these log files. So log file is something that you write down what happens in your program, and then you would like to search within this log file and find errors. And you have noticed that apparently this is not an error, it's an info. Just the text of it is called error. So you need to be flexible on this. For example, to provide statistics. So these are just generic examples, just to give you some idea how to use it. Now, where can you use it? So on the command line, on the Unix command line, there is a command called grep or egrep. that allows you to fetch, to go over a file line by line and basically show the lines that match some regular expression. There are all kinds of Unix tools, Unix Linux tools that you can use them, editors, and then all of these programming languages, and I highlighted Python here, but I mean, every programming language, you have regular expressions. There is also a special library called PCRE, which stands for Perl Compatible Regular Expressions. And that's it's a library that you can use. I mean, programmers who write programs in C or other languages, they can embed it, and then they can have their own program have regular expressions. And they are called Perl compatible because even though regular expressions were before the Perl programming language was created, but the Perl programming language made them a lot more mainstream. And that's why, and extended a lot of the regular expressions. So that's why also what you have in Python, that's mostly Perl 5 compatible or Perl compatible, but it has all kinds of extensions that Perl either doesn't have or have it in a different way, because they at one point they split the engines behind it. One major thing that I should come back here is the connection between the environment and the regular expression language. So when you're talking about things like grep and egrep, then the regular expression is totally external of the environment. In Perl, which is the other extreme, it's embedded. It's like one more operator, just like plus or equal. It's just an operator. And most of the other programming languages, including Python, it's a class. It's a separate class. So it's not as embedded as in Perl, but it's still much closer than being totally external. And we'll see a couple of things why it's interesting. Anyway, just to show you what this grep thing can do. And I don't know how can you have grep on Windows? I'll figure it out later on. Actually, when we talk about when we have the separated videos about Git and version control, there will actually install a Linux-like shell on Windows, and there you'll be able to use grep as well. But let me just switch to the screen and show you this thing. So let's see. Okay, let me go back to the place where we have a file called, I think there is a file XML. So files, oh, it's not XML anymore, okay. MD, okay? It's just old slide, but it doesn't really matter. So I just run grep, Python, and files. So what I did here is I told the program, told this grep program, look for this regular expression, which is a very simple regular expression, just letters, in this file, and print out the lines where you have a match. Okay, so these are the lines. It also highlights the word Python. So these are the lines where we have Python in the whole file. Okay, I can say something like this, 3, 4. Okay, let me see. I don't know if it's I haven't updated the slide. So yes, okay. So now I'm checking. Oh, I'm printing out. Okay, so this just goes over line by line, checks whether this regular expression matches that line in the file, which is called filesmd, and prints out the lines where they are matching and highlights the match actually. So here you can see that in this line, there was the 3 and the 4 both matched. In this one, the 3 matched. So this expression basically says match either 3 or 4. Okay. Here I'm just saying that do it on all the files. That's here I'm saying that match anything that has any digit in it. So 0 to 9. Okay. So any of the places where you have any digits. Okay, it's already full screen here. And then this goes even further. So let me try this one. Let me see if there is anything in there. I think you need egrep, but doesn't matter actually. Apparently this grep also worked. So this one is different from the previous one. You see, this one has these rows. Okay, so this one says in this \b, we'll see the actual example in this, says that in front of that digit, you don't have another letter or digit. You have a space there or a parenthesis or some other thing that's not part of the set of letters and digits and underscore. So that's a special set. So it's like the beginning of a word. That's how I usually say. Okay, so that's just using grep. And now let's get to Python, okay, because that's what you were waiting for. So in order to use regular expressions in Python, you need to import the RE module. That's what provides you the regular expression engine. And then we have some text, okay, just some text somewhere. And then there are several ways to use this regular expression module actually, the RE module. The first one that we saw is using the search function. So we say RE search, and then we give it a regular expression and the thing that we are searching on, so the string that we are searching on. And you see that there is an R at the beginning, even though this string doesn't need, but if you remember the first slide where I showed that the language, there were a lot of these signs that started with a backslash. And we want to make sure that the backslash remains there for the regular expression engine. So therefore, we are using the row strings. And even though in this case, we don't need it, but I said, okay, let's start getting used to it from the first slide. So this is just, I'm looking for the series of characters LAC, just one after the other in this text. And because it's here, okay, so what we get back is a match object. So something that represents the whole matching thing. And we can ask it if it's true or not. Okay, so I can say if match. Okay, because this object can, like you remember, you can ask if any variable, and that would be basically true if the variable is not empty. It's not none or null or zero or empty string, or so the empty thing of that kind. So basically this regular expression, this function will return a matching object, or it will return a none if there is no match. And none is considered to be false. Okay, so I can ask if match, and then I just print that there is matching, just some text. And I also print this match.group0. And in a second, I'll explain what this whole group 0 means, but it's actually going to print out whatever this regular expression matched. In our case, it's not very interesting because I had a very specific string to look for, and well, it found that one. But if I'm going to look for digits in general, then it's going to be interesting what digits were found. Okay, so when my search is not exact or not specific, but can be flexible, then it's going to be interesting what was the actual match. Okay, and why are there group 0? We'll see that you can have more of these groups later on. Okay, so this is when we have a match. What if I'm looking for a dog in this string? There's no dog, there's cat. Okay, so the match object is going to be none. So the if match will be false, so this won't print, but the else part will, which will print out did not match. And if you print out the match object, you will see that it's none. Okay, usually you don't do that. Usually just you do if match something. I just wanted to show you what happens here. Okay, so this is like the basic thing, basic way how to use regular expressions in Python. Okay, now let's do something a little bit more interesting. So here we have a line, a text again, which has some text in it and some numbers. So far, so good. And now I'm saying regular expression search for \d plus on the line. What I get back is that there is a match, and the match, the group 0 of the match is a 1, 2, 3, 5, 4. 5. Okay, so for this set of the digits. Okay, these digits. Okay, so okay, why is that? Backslash this means match a single digit. The plus immediately after means take whatever you take this matching thing, so backslash d in this case, this operator, let's call it, this sign, and match one or more of these. So the plus sign is the quantifier. It tells me how many of them. The backslash d would match only a single digit, but because of the plus, it matches one or more, and there are 5. And they also have to be consecutive, so that's why it doesn't match the rest of the digits in the string. Okay, so this is what it is. And so now we can see that the group 0 already has some value because it actually prints out the digits. Okay. Any questions here?
I mean, I'm still not quite sure about why like 0, but I suppose we'll get to that group 0.
Yes, yes. I'll
Yeah,
talk about it in a bit. Okay.
Yeah, no, the rest is okay.
So group 0 is always whatever the regular expression, the whole regular expression matched, that's gonna be in group 0.
What happens if there are multiple hits?
So here we could have multiple hits, right? Because there are digits here and digits here.
Yes.
Okay. But the search function, as it is, will return the first match.
Right. Okay.
Okay. It always returns just the first match.
Okay.
We'll later on talk about how to match the other one.
Okay.
Or others. Let me just peek ahead. Yeah. So you would like actually to so your question is actually how to match the other digits, right? Or actually
not exactly. So I was just thinking that if you have more than one hit, they could be different, right? And what would group 0 return then?
Yeah, so you can't really have more than one hit because the search always returns 1, the first one that it matched. Okay, there are other functions that's another function that can return you all of the things, but it always matches the first one that it can match. Okay, but the other interesting question here might be that, okay, but why did it match the first set of digits, and how can I convince it to match that 23 at the end? And then comes my question, okay, how do we recognize that 23? How can we describe it? So how could you describe that 23 to someone, to even just a person? What is that 23? Is that
it's the age, isn't it?
Well,
so you could, if it has a meaning like that, it always has like age colon before it, then
yeah. So it all depends. It's very interesting because when in my courses I ask these people, and some people say, well, this is the second number. Some people say, no, this is what comes after age. Some people would say this is the last number in the string. So you can describe this number in various ways, and depending on how you describe, you will need the different regular expression, of course. Okay, but you have to be able to describe, so a human being will be able to do this. Without that, you won't be able to write the program. So in our case, what he said, okay, let's go with this age thing. So there is age colon, a space, and then some digits. Okay, we were that specific in this case. So this is what we have, the regular expression: age colon, space, and then digits. And if I look at the match and group 0, then I see that it matches age 23. So exactly what I told it to match. Okay, and so far it's good, but we are actually interested in just the number 23. We had the age colon space in the regex only in order to explain to the engine, the regex engine, which number to capture, which number to match. Okay, so we can add a pair of parentheses around the digits. What it does, it doesn't change what is being matched. But what it does, is that it creates an additional group called group 1. And in group 1, we will have whatever the pair of parentheses matches. Okay, so group 0 is always whatever the whole thing matches. And then you can have group 1, group 2, and so on, whatever these pairs of parentheses match. Because you can have multiple pairs of parentheses in your regular expression, and then they will, whatever they match, they will get into group 1, group 2, and so on. Okay, so in this case, group 0 is still the age 23, exactly as earlier, but now we also have a group 1, which is 23, which is what we wanted.
Now, the interesting thing would be, how do you search for something that is, you want to look for something that is in between parentheses?
Okay, so you would actually want to match a parenthesis.
Yes.
Okay, so in that case, you need to escape the parentheses, the special character. You remember how we escape things?
Not quite. I mean, we use this. Yeah, go on.
The backslash is the usually the
right,
escape character.
right.
So you put a backslash in front of it, and then Python will say, okay, that's just a regular opening parenthesis.
Okay. So
okay.
it removes the special meaning to it.
Yes, exactly.
Okay.
So, but on the other hand, with the D, the addition of the backslash made it special. Okay?
Right. Yes.
Okay. And you remember at the beginning of this chapter, this part, I mentioned that in some places the meaning is reversed. So in some places, the parentheses are just parentheses.
Yeah.
And in order to use them as what we are here, you have to escape them. So okay, it's just a mess. It's in different languages, so don't worry about Python. Python is always like this, but in some environments you might need to rethink how you put these things together.
Right.
But that's just because regular expressions is just so different in other places. Anyway, we can also have a method called groups, which would return all the groups that were matched. Okay, which in this case would include this one, 23. Apparently it doesn't include the, let me run this, maybe it's a wrong Python, and it was called capture. Right, okay, so it includes 23 only. Okay, so these groups apparently doesn't include the group 0. Okay, what it returns is a tuple of all the groups from 1 and above. In our case, we only have 1. Okay, and you can ask the length of it and it will say 1. Okay, obviously. And this extra comma here is just because the way tuples work. Okay, when you only have 1 element in a tuple, you need the training comma. Okay. So what if we have these, what if we do with something, okay, what is the story here? Yeah, so what if we are looking for anything colon at digits, not necessarily age, okay, just some word, colon 23. Then we can write this regular expression. So at the first we have a pair of parentheses, and inside there is a \w plus. \w is any word character, which basically digits, letters, and the underscore. This is like the definition of \w. We'll get to the more specific definition in a couple of slides. And then we have a colon, then a space, then the digits, as earlier. But the point here is that we now have 2 pairs of parentheses. Okay, well, that's one part of the point. And then we have the match, and the group 0 is still age 23. Group 1 is now age, because this is the first group, and group 2 is 23. So first of all, why is this group 1 and why is this group 2? The counting is from left to right and based on the opening parentheses. And it's actually important because you might have a pair of parentheses inside another pair. and then the external one is going to have a lower number because it starts earlier, even though it ends later. But the factor is where it starts. Okay, so that's good. But you also notice that now the group that contains the number has changed from 1 to 2. The previous one we had 1. So you have to be careful when you're adding parentheses or removing parentheses. Then you might need to adjust your code as well. Okay. You might want to try accessing group 3 here, of course, and you will get an index error because you don't have groups get age and 23 in this case. So the tuple, and that's it, and two elements. So that's not very surprising here. But this is really nice, I think, that you can capture various parts of the regular expression of the original string using these pairs of parentheses. Okay, so this is okay. So this is just an example when you have an extra pair of parentheses around them, and then you can see that group 1 is, well, in this case, it's basically the same as the full regular expression. So there's nothing very special, but but this is group 1. This is group 2. This is where group 2 starts. See, only this, and then this is group 3. So this is just showing that that thing that can be problematic. Okay, so let's come from the other direction now. What if we would like to find the second pair of numbers, the second number, so like second set of numbers, or the third set of numbers? In order to do that, basically, you need to, I think the best way to do that is to use the findall method instead of the search. That will find all the various places where there is a match, okay? Or more precisely, all the various non-overlapping places. Okay, so if you had one match, then the next part of the search will start from the end of it. Anyway, here we have the \g+, which is just matching digits. The findall will return us a list. So it's just a regular list. It's not a special thing. It doesn't have a group method, nothing like this. It's just a list of the actual matches. So in this case, it will going to be the list of these two numbers, or two strings that contain numbers, okay? Because they are still strings. Okay, as you can see, they are still strings.
Yeah, that's what I was gonna ask actually. Can you, without having to modify the list later, but because the regular expression is already looking for digits, isn't it?
The regular expression doesn't really understand that these are digits.
Okay.
So the regular expressions, for regular expression, these whole things are just characters.
Right. Okay. So there's no way to already turn it into integers or something.
No. So you have to really. Yeah. So the regular expression doesn't understand all this meaning actually to digits. It has just a sign for those specific characters that we call digits.
Okay. Yeah. Fair enough.
Okay. Okay. What if your string doesn't contain anything that can match? Well, in this case, no problem. You get back an empty list. So not a none, it's an empty list. Okay. And of course, you can check it if it's empty and so on. Okay. So what if now we have capturing, so parentheses, and we are using findall. Okay, so here we have this. This is the example that I'm going to actually trying to show. So let's go step by step. So this is the string, the original one, the same two numbers in there, and we have now the expression says just catch some word characters, so some text, space, and some digits. So we can see that you can find it here, and you can also find it here. Okay. So we are using search. It will find the number and 1, 2, 3, 4, 4. Okay, the first thing, whatever it is. Okay. What if we put parentheses around the second one and we still use search? Well, the group 0 is still going to be the same, and group 1 is now the digits only. So far, what we learned. Find all, if I run find all, but the same regular expression we had it here, we get the both sections where we have some word and some number. And now I put up the pair of parentheses, put in the pair of parentheses and do find all. What it returns to me is the matches that the pair of parentheses matched. So now it disregards all the rest. And the list is going to contain only the digits, only the parts of the numbers. Okay, because we had parentheses. Okay, so far so good. So what if we have more than one pair of parentheses? So in the search, we will get group 1 number and group 1 the digits. And in the find all version, we will get a list of tuples, where the each tuple contains the parts that are matched by the pairs of parentheses. Okay, so this was the first match, this was the second match. Okay, we are getting a little bit too much details here, but just a general overview. Now we get back more to the actual language of the regular expressions. Yeah.
Sorry, yeah. So in the previous slide, is there any way to get the tuples of first the words and then the other tuple with the numbers?
Oh, sorry, I don't understand.
So instead of, now we are having tuples which contain a word and a number.
Yeah.
And then could we get all, like find all of them, but separate the words into one tuple and the numbers into
all the words in
tuple.
one tuple, all the numbers.
Yes.
I don't think that the regular expression engine provides anything like that.
Right. Okay. Okay.
So, but you can go run some function on this that will do the separation.
Yeah. Okay.
Okay. Okay. So more about the regular expressions, the language. Dot, okay, a single dot, this one, matches any character except new line. Okay, so for example, you can use something like this, hash mark dot hash mark. And it will match anything where you have a hash mark, a single character, and another hash mark. Okay, so here I have a bunch of strings, and I go over them and print out the string, and then run the match with this regular expression and print out if it matches. So I don't have here the output. Let's go over. So you tell me which one matches.
Okay, first one doesn't match. Second one should match.
Yeah.
Third one should match as well.
Okay.
And then I suppose the fourth one as well.
Okay, this one?
No. Actually, yes, because of the end.
Yeah.
Yes, sorry.
Yeah, I was trying to point this one.
Yeah, I was looking at that too.
Yeah, okay.
Yeah, the next one shouldn't match.
Why not?
Because, oh wait, so this just means like hash mark dot hash mark. Does it mean only one character?
Exactly.
So then this shouldn't match because at the end there is a space and a C, so that's two characters.
Exactly, and that's an important see why in most cases we think about the space character as just nothing.
Yeah, no, it is a character.
It is a character. It has a meaning there. Yeah. So this doesn't match. Yeah.
The next one, I don't know if, I mean, the at is also a character, isn't it?
Yeah, it's just a character.
Yeah. So it should return that. Actually, I was thinking about the next one. That should be a match as well, but I didn't know. That was actually going to be one of my questions. How do you look for something if you actually want to find only a dot?
So do you remember the parentheses?
Okay, the parent. Oh, right. Okay.
So
not the backslash.
Yeah, you put a backslash in front of the dot, and then it will just match any dot.
Yeah. Okay. Yeah. The next one should match as well. Oh, sorry.
No problem. I'm just connecting my earphones so it won't beep me.
Ah, right.
Or at least I won't hear it.
Yeah, the next one should also match.
Right.
And that shouldn't, I think.
Right, it doesn't matter.
Because there is no character
There's
in
no
between.
character in between the two.
Yeah, the last one should match though, shouldn't it?
Yes. So the first hash mark will match the first one, the dot will match the second hash mark, and the second here will match the third hash mark. Yeah, right. Okay. There is actually a comment here that you can use a flag called re.all. I think we'll have a slide later on to change the behavior of dot to also match new lines.
Right.
Okay. Okay, so here is what you asked, how to match a dot. So \dot. Okay. Actually, there's another way to put them into square brackets. We haven't learned about the square brackets yet. It's what we call a character class. We'll learn about later, but this is shorter. So, right. And I don't think anything else here in this example, just showing that the \dot. Okay, so let's see that you have some text again, and you would like to match any of these. So in all of them, you have two hash marks, and in between there is either A, B, C, D, E, F, or an @ mark, or a dot. So
the one with the space and the one with the hash mark in between, the two hash marks wouldn't be matched.
Wait
right?
a second, we don't have the regular expression yet.
Okay. No, just I'm looking at the ones that we're looking for, so we don't want to get that back, right?
This one we don't want to get.
Yeah.
And which one not?
The one with the spaces and one with the hash mark.
Not this one, not this one, and not this one, right?
Yeah. Okay. And not the Q one actually. The second one, because that's a Q and we don't have
the Q one
with the Q.
and not this one, I think.
We have that.
No.
Oh, AB, right.
AB,
not that, yeah.
Okay, right. So this is how the regular expression looks like. Okay, so we have the two hash marks, and I'm using them only just to have something around them. Okay, yeah, they're just there. They're just regular characters. Nothing. There's no special meaning here. What we have here is a pair of square brackets, and within the square brackets we have all the characters that we would like to match. Any of the characters that you would like to match. Okay, this is what we call a character class. I would say a list of characters if I wasn't afraid that the word list would make people think that it's like a Python list. Okay, because it's sort of not. So it's not. It's separate. So I just put in all the possible characters, and this character class will match exactly one character out of this. So that's exactly what we went over earlier, that it, for example, won't match this one. Even though both A and B are here, it won't match. Any other comment here or question?
No, not for now.
This dot doesn't bother you?
Oh. Okay, so shouldn't there be a backslash there?
Yeah, so I think actually.
So this only returns AB.
This case, you remember?
Oh, okay. Yes. So if it's in a class, then it doesn't matter.
Yeah, if it's within a character class, then it loses its special meaning.
Okay.
Okay?
Yeah.
Yeah. So here it just says A, B, C, D, F, or an @ mark, or a dot.
Okay.
And the single one exactly. Okay, so far so good. So this is the regular expression. But we are lazy, as you know already. Programmers are lazy. So it's better to write A-F. Okay? Because in this case, the dash here means from to. Okay? Within character classes. So it allows us to write less text there. Okay, and especially it's good for people who don't really know the ABC, because then they won't miss any of the letters in the middle. Okay, so this is just the same. Okay, so the common character classes. I mean, you can put in within square brackets. You can put anything. Okay, and then you have a character class. But because there are many, because there are a few sets of characters that are very commonly matched together, the ancient people in the early days created a couple of these special character classes, and they have a special sign for them that we've already seen actually. One of them is the \d, which stands for digits. And just to clarify, this is what you would think of as digits, but this is not, these are not the only digits, okay? Actually, there is this table I have linked to where it shows all the Unicode digits. So these are the ones that you are used to. And then these are the ones in Arabic, okay? And then some extended Arabic. And NKO, which is an African language in the south, so southern, not South African, but in the southern area of Africa. It's not a language, it's a writing system, I think. And they have their own digits. And Devanagari, which is somewhere from India, okay? And there are a couple of other of these letters that are in what we call the Unicode, not letters, or characters, that are digits, that are actually numbers, okay? That are in the various Tamil, okay? So these are the various writing systems. There are a few here that I think they couldn't even print here, okay? And we'll see there a couple of these examples. So one has to be careful, especially people coming from the older schools, because in older times, \d was really just matching these digits. But these days, especially Python 3, they match any of the digits. And you can actually use a flag, and you'll see a flag to restrict it to match only these digits. \w is it would be these, the letters, the digits, and the underscore, but it actually also by default matches all the letters that are in any of the ABCs in the world. I think that's the thing. And \s is a special character class that matches any of these special characters, which are basically these form feed. I'll tell you what is it in a second. Tab, so this is the tab character, the new line, the carriage return, we talked about it, right? The typewriter thing, and a vertical tab, and a space. So the form feed and the vertical tab are slightly unfamiliar. I actually have never encountered a vertical tab, I think. So I don't know what is that. A form feed is a long time ago, when printers were much bigger and people wanted to have a new page, they had to send this character to have a next page, basically. Almost never used, I think, these days. But still, this \s matches any of these, what we call white spaces. Okay?
Wouldn't a vertical tab be like something, for instance, in Microsoft Word, when you say like, leave this much space between paragraphs? Would it mean that?
I don't think so, but I don't know.
Okay.
I have no idea where it's used.
Okay, fair enough.
Here I have some typo. The thing here is that you can use this character class either by themselves, okay, match a digit, or put a quantifier on it, as we saw it, so \d plus, or we can create a bigger character class saying, okay, it contains any of the letters A, B, C, or any of the whatever was in the \d. Okay, so that's can be also used to build a newer character class. Okay, a couple of examples here. Let me see if the slides work. The slides work. I just put them on. So here are some strings basically. It is the number 2 that's commonly used in the Latin letter countries, and commonly used in the Western world, which is actually the Arabic numbers, but that doesn't matter, just too confusing. And then the Arab, which the Arab countries are using these days. This is number 3, and then other ways the Unicode. So these are all Unicode characters. They are all in the Unicode table. You can easily, it's hard to type them in other keyboards, but people type them all the time in their native keyboards or in the sets. So this is just I copied it from that table. So I basically copied from here. Okay, these letters or digits. So these are just the number 4 in NKO, which is what I said is West Africa. Sorry, I messed up. Not stop. This is the Indian, and this is a Hebrew Aleph letter. So it's a letter, even though it's sometimes used as numbers, but it's more commonly used these days as a letter. So I just had these to see the examples, and then what I did is I ran a search with \d on them and checking which one matches. And this is what I mentioned earlier. You can also pass here a parameter, an option, which is in this case re.ascii, and that changes the behavior of \d to be only the Latin digits, or let's call them Latin for now. Okay, even though they are not. That's not messed up. Okay, so the digits that we are used to. Okay, so this one matches in both cases. The Arabic one matches the \d, but not when it's ASCII. The half and the circled 2 don't match any of the cases. The NKO matches the \d, but not in ASCII. This one was the Devanagari that matches. Dash and underscore, they don't match, of course, they are letters. I just have them because in the next line we are matching this with \w. And then none of these matches because they are all either letters or just signs. And then here I have the same examples, but this case with \w and also with ASCII, \w with ASCII. And you can see here the examples. And of course, at the end of the course, we'll have an exam. You have to remember all the 4,000 characters and which one is a digit and which not. Right. So I was just really interested actually just a couple of hours ago and updated these slides because I haven't used this flag earlier. So I just assumed that \d was matching the digits that as we use them in programming, let's say. But apparently it's incorrect. So I have to either change my code, go back to all kind of places. So I have to change my code, either matching the square bracket 0 to 9 or put the ASCII flag on them if that's what I would like to have. Okay. In bioinformatics, probably we won't encounter any of the Unicode characters, but it's still good to know somewhere in the back of your mind that it's not exactly these. Okay. So in the character classes, you can put a caret. Okay. You know that this word caret, right? For this character.
No.
Okay, I never know how to exactly pronounce it. It's not the carrot, not the one that you're eating.
No.
Carrot.
Carrot. Yeah, I know what you mean, but I don't know the correct pronunciation either.
Okay, so whatever. Okay, is the roof of a house. Okay, so that's how it looks like. Okay, and if this is the first character, then what it means that this character matches any character that is not listed here. So instead of saying I am looking for all these 65,000 characters or any of them, I'm just saying the 3 that I don't. But if this still matches exactly one character, Okay, so it's important to remember that it still matches exactly one character, this one. And because this is common, slightly common, we have the \d and the \w, and the \s have their counterpart, which is the negation of them. Okay, so the capital version of them is the negation of the same lowercase version. So this is any character that's not a digit, in general digit.
So here, if you wanted to look for something that's longer than one character but doesn't have A, B, or C in it, then you could put a plus, right? But where would you put that?
Yes, after the \d, after the \D.
Okay. No, I meant in like the first one. So A, B, C.
After the square bracket, we'll have
after the bracket. Yeah. Okay.
Yeah, after the closing one. Yeah, we'll see it in a second, but yes, after the closing one. Okay. So now we're going to talk a little bit about quantifiers actually, and this is the standard joke I have for all the people and the laughing at the English spell. Well, I would say differently, but they would say, no, we are writing correctly and you're writing differently. Anyway, so some people spell color this way, some people spell color this way, you might have a text that you would like to match either one of them. Okay, so the question mark is an operator in the regular expressions that works on the preceding whatever you have, so in this case the u, and says that this thing can either appear or not. This is a quantifier, so what we say is it can appear 0 or 1 time. So not appear or appear. Okay, so therefore this regular expression will match this color and this color, but this won't match this one because u can be there 0 or 1 time, but not 2. Okay. So this is good for this case, but it can be good on all kind of other places where you might have an optional dash. You remember the flight ticket? So there might be a dash somewhere. So I would put it, okay, so you can have a dash and I put a question mark on it because you don't have to have it. Okay, there is a third quantifier, which is a star. A star means it also works, all of the three work on the thing that before them, on their left side. Okay, so in this case, the dot. Okay, the star means 0 or more. So in this case, and dot means any character. So dot star means any character anytime you want, or anytime it appears. Can be 0, can be 700,000. Okay, it doesn't matter. Okay, so here we have a dash, then dot star, then another dash. So which one it matches if these are the inputs?
Not the first one, not the second one. The third one, yes.
Yeah.
And the fourth one, yes.
Okay.
And the fifth one, yes.
Yes, exactly. Okay. So basically you need 2 dashes in there. That's the whole thing here.
Yeah.
Okay. Okay. In general, these are the 4 quantifiers basically. Okay. The 3 common ones. So the star means 0 or more. The plus means 1 or more. The question marks means 0 or 1. So if you look at these examples, you can see star means 0 or more x's. Plus wouldn't match this one, but all the others, yes. So 1 or more. The question marks matches 0 or 1. And then there is this curly braces, pair of curly braces, which can also be used. It's much more rarely used. It allows you to say that the x appears between 2 and 4 times. So it's way more flexible, but you don't need that flexibility. So it will match 2, 3, or 4. Or you can also see, yeah?
Sorry, could you say 2 or 4 times? So no. It wouldn't return 3?
No, not this way.
Okay, okay.
Okay. So not with these quantifiers. We can see an example to how to do that actually. 3 or more. Okay, so 3, 4, 5, whatever. And this would mean exactly 17. Okay, just count it and, okay, 17. Okay. Let's look at this a little bit more. Maybe we'll have to a break or not, I don't know. Tell me if you feel that you need to have a break in the video and then we can continue in a separate video.
I mean, we already did 1 hour.
Yeah.
Maybe it's better to have a break.
Okay, so let's have a break now and then we continue because we still have a lot more. Okay?
Okay, all right.
So thank you for watching so far, and then we'll get to the, yeah, we'll come back in the next video and we'll continue the regular expressions. Okay? So see you in the meantime. Bye-bye.
See you.